Hello, my name is Liz Thompson, and this is IME 315, Financial Decision Making for Engineers. This video is on break-even analysis. So if we look at the 5 areas in which we're covering in this class, this video is related to cost of products. So when we think about break-even, I'm going to be sort of going a little bit more slowly and looking at this graph as a way of explaining break-even analysis. So the graph is y-axis is costs and the x-axis is sales volume. And if we think about costs, we know that in some situations there's a fixed cost that we've been talking about, and then we add to that a variable cost. So then when we look at both the fixed and the variable cost associated with a product, that we get this idea of total costs. And just like we talked about before, this is the same as the sort of standard equation that you're used to when you look at y is equal to mx plus b. In this case, m is the slope, or is the variable cost associated with this cost curve, and the b value is the fixed costs. So we can kind of rewrite it in this way. C, the total cost, is equal to the variable cost times the volume plus the fixed costs. So it's the same exact equation here. And if we look at that, we can change the y-axis to dollars and then lay on top of it a revenue curve. So if you remember when we were looking at profit and loss statements, it's revenue minus total cost is the profit associated with it. And this particular place right here is actually called the break-even point. And what that means is that above this break-even point, and this point is where total costs equal total revenue, above it, the company's making profits, right? Because the revenue value is above the cost value. So this amount is profit. Below that is losses. In this case, the top cost value is above the revenue, and so we have a loss associated with that. And so in order to solve for this, to look at what is that X value or the volume value such that we have this switch from profit to loss, we can put the cost curve here, and where I just defined these variables as this. And then we also can include a revenue curve, which is, if you remember when we were creating the income statement, it's the price that we sell the items for times the volume. So now we have these two curves, the two lines that are described by these equations. If we set them equal to each other, we can find out the place at which the volume is, what the volume is when they're equal each other. And when they're equal each other, that's a zero profit place. So just rearranging this with algebra, we get the volume is equal to the fixed cost divided by the price minus the variable cost. And that is what's known as break-even volume. So let's look at an example. We have here, the variable cost is $10 per unit and the price is $23 a unit. So when we put that into an equation, we can figure out what the break-even volume is, meaning the volume such that the profit is 0, or the volume such that revenue is equal to total costs. And remember from algebra, we have this equation, so we're just going to plug it in there, and that means that 77 units is our break-even volume, and it would be units per year because the fixed cost is dollars per year. And that means if we produce more than 77 units, we'll make a profit. If we produce less than 77 units, we will have a loss. Then that's really the concept of break-even, that point at which we switch decisions from profitable or loss to profit. Another question we might have here is, what is the break-even cost, the price at which we start to make money? So we have price versus volume in the revenue line. So in this case, we don't have volume as the x-axis, but we have price as the x-axis, okay? So as price changes, the revenue will go up, but the fixed cost is not impacted, or the total cost is not impacted by price. So what we're going to do here is look this a little bit differently, and we're going to say, at what price do we start to make a profit? So as we increase the price, this revenue line starts to go above this cost line. So this point right here is the price at which we start to make a profit. So if we rearrange this equation, we can see that price is equal to variable cost times volume plus fixed cost divided by the volume. And that means in this example, the break-even value here can be solved in an example. So let's look at another way of looking at break-even is when we look at make versus buy. So what we're going to do here is we're going to say what happens is if we make a product, this line here, we have some fixed costs associated with it, maybe some machinery we have to buy. If you remember when we were talking about fully allocated costs, this might be the overhead costs. And then with this increases over time because we have for each unit we produce, the variable cost goes up. So that's the total cost line of making the product. But in the other instance, we might actually make a decision about buying this product instead of making it in-house. And so in that case, we have the total cost of purchasing a component. So this might be something like, are we going to make a subassembly or are we going to buy the subassembly? If we make it, we have to buy a workstation, we have to pay an employee, we have to do all kind of fixed costs. But if we purchase it, we just have to pay for the unit that we buy. Each unit we buy, we have to pay for. So this is a very common question in industrial engineering, whether we should make or buy something. And so if we end up making it, if we look at the price, the production volume such that above that the lower cost value it's lower cost to make than it is to buy. But down here, it's lower cost to buy than it is to make. So again, this is a break-even point, whether the decision is make versus buy. So the total cost of manufacturing it or making it is the variable cost times the volume plus the fixed cost. The total cost of buying it is the cost per unit times the volume. And again, we set those equal to each other and we can find the break-even volume here. So as an example, we could say here that it cost $5 a unit to make and there's a $10,000 fixed cost. It costs $7 a unit to buy. At what volume is it better to make it? And the break-even volume here is 5,000 units. You might want to verify that yourself, but that means that if you make more than 5,000 units, then you should make it, or you need more than 5,000 units, you should make it in-house. If you need less than 5,000 units, you should purchase it from a supplier. So again, looking at the 5 areas of this class, this particular class was on cost of products.